All right, this is the second part of the Chapter 3 video on infancy and early childhood physical development. So let's go on and look at the nervous system. So much is happening with the nervous system in infancy, in the early childhood years. So let's do a quick little review of the nervous system. What is it? It is one of the communication systems of our body. All right. The basic unit is the neuron, which is a cell in our body that allows us to transmit information. All right, to get our, say, muscles be able to respond. All right. So here is a neuron. Let's look at the different parts. You should remember this from introductory to psychology, so we won't spend too much time on it, but let's review. So the dendrite is the part of the neuron where the information goes in. So dendrite, right, is the right way for information to go into the neuron. Dendrite, right way for the information to go in. All right, so the information will go in through the dendrite, and through electrical process, the information will go down through the axon and out through the axon terminal. Okay, so information goes in through the dendrite, through the cell body, down the axon, and that all happens through an electrical current. Okay, and then when it goes to the axon terminal, neurotransmitters, which are chemicals, get released into the synaptic gap. The synaptic gap, or the synapse, is this gap in between the neurons, okay? So neurons don't actually touch. There's this synapse, the space in between, that neurotransmitters get released from over here, from this one neuron, get released into the gap and get the other neuron excited or get it to calm down. All right, so if it gets it excited, maybe it'll get a muscle to move in response to this message. Okay, so neurotransmitters are these messengers, these chemicals that carry information from one neuron to the next. All right, so on the axon here, there's this myelin sheath, which is like this fatty coating that helps messages go through the neuron so fast, go through the axon much faster. And as we mature, this myelin sheath, it will increase, okay, especially in early childhood years and through adolescence, and it's called myelination. So you'll hear that term again. Myelination just means that the messages can flow through that neuron, flow through that axon of the neuron so much faster. Okay, so let's see. The mature brain consists of billions of neurons. And it's organized, these neurons are organized into nearly identical left and right hemispheres of the brain, okay? And it's connected by this thick bundle of neurons called the corpus callosum. And you remember all this from intro to psychology when you learned all the different parts. All right, so let's look at the emerging brain structures. So I want to point out that by age 6, the brain is at 95% of its peak volume. So by age 6, all that development and growth is happening in the brain. All right. So then 5% of the volume is left to be acquired after age 6. So much is happening in those first 6 years. All right. So about 3 weeks after conception, the neural plate forms, which folds to make a tube which eventually becomes the brain and the spinal cord. So this brain development starts happening at 3 weeks after conception. In the 4th month of prenatal development, axons begin to acquire myelin. Remember, myelin is that fatty coating that will speed up those speed up the messages going through the neuron. And synaptic connections that are used are strengthened, while those that are not usually will die. That's called synaptic pruning. So much is happening in infant brain development. There's this myelination, that fatty coating happening on those axons to allow the messages to go really fast through. There's synaptic pruning, where getting rid of those gaps in between neurons that do not get used. So if the baby is not being spoken to or not being exposed maybe to a lot of stimulus, you start seeing some synaptic pruning. Some of those synapses, those spaces in between neurons, die. They go away to allow the brain to become more efficient, essentially. So synaptic pruning, cell death, and myelination improve efficiency of the nervous system / brain. So it helps to improve it, but at the same time, what's a little bit scary about the cell death, the synaptic pruning, is that if a baby is not being stimulated in the early years, some of these cells are dying off, or some of the synaptic gaps are being pruned away, which can result in later developmental issues. And that kind of leads us to talking about neuroplasticity. So neuroplasticity or plasticity refers to the modifiability or molding of the brain. So our brain, we're not born with like this brain that then just stays the way it is. No, all of our experiences, both positive and negative experiences, change our brain, molds our brain. We create more synaptic gaps in between those neurons that tend to fire together. And as part of the additional videos, there's this video that will explain neuroplasticity, that will explain all that is going on in an infant's brain. So you'll be able to learn more about that. So environmental stimulation is important in normal brain development. Environmental input influences experience expectant growth. So it has to do with the wiring of the brain. It is organized by experiences that are common in most humans. So as we have these experiences, our brains rewire, and certain wiring becomes stronger. These certain neurons are going to fire together the more times that you have experiences that make those neurons work. So it's quite amazing what is happening in an infant and early childhood's brain. So let's look at motor skills, so moving and grasping in early childhood and infancy. So let's look at what's happening. So you have this fetal position in newborns. Around 1 month old, they're going to be able to hold up their chin. They're going to be able to hold up their chest around 2 months. They're going to be able to sit when supported around 4 months. Sit alone around 7 months. Stand holding onto furniture around 9 months. Crawl around 10 months. Be able to take some steps if held around 11 months. Stand alone around 11 months, and be able to walk alone around 1 year old, about 12 months. Now, these are all estimates, okay? So it doesn't mean that if a baby is 1 year old and not walking that they are behind. These are just complete estimates. Some babies are going to walk earlier, some babies are going to walk later, all right? And some babies don't even crawl at all, so that's not even a concern. Some babies are going to go from just standing right to walking and completely skip crawling. So these are just estimates. All right, so let's look at this theory called dynamic systems theory, which says that motor skills don't develop by maturation, like us maturing alone. Rather, it is an interaction of children learning from past experiences. So this dynamic systems theory says really that little ones try out something. Maybe they want to get to, say, a toy. They're going to try maybe to move one leg a certain way and then move another leg, and maybe it doesn't work out and they fall. So they try to do something a little bit different. So dynamic systems theory really says a lot of trial and error is going on here. Little ones are learning from past experiences. They're making changes. If they fail at something, they're going to learn to move their body in a little bit different of a way to be able to accomplish their end goal. All right. So let's look at, so fine motor skills refer to a lot having to do with picking up little things, using your hands, these fine motor skills, using the small muscles. So newborns use an ulnar grasp Okay, so if you take your hand and you put all of your fingers together, and then you put your thumb by the side of your hand, and you just kind of make it look like kind of like a claw action. All right, so it kind of looks like the shape of a U, so don't use your thumb, just use your fingers and in the palm in the palm of your hand. So so sometimes it's called the palmar grasp or the ulnar grasp, and really little ones just kind of swat at things to try to grab it. They kind of claw at things. So they have their palms and all their fingers, and they're using this ulnar, this grasp in the shape of a U with fingers in the palm, and just kind of swatting at things and trying to grab it. There's not much coordination happening there at all. As they get a little bit older, they start using this pincer grasp, and that doesn't really happen till around about 1 year old. It's more using their thumb and their index finger maybe to pick up things like cherries. Cherries or Cheerios is what I meant. So being able to pick up those little tiny things, that requires a pincer grasp, and that doesn't happen until around 1 year old. Newborns are using that ulnar grasp, that palm and all their fingers, and they're kind of just swatting at things, okay? And sometimes they'll grab a hold of it, sometimes not so much, okay? And then gross motor skills have to do with your bigger muscles. And around 5 years old, they start to be able to hop, go down stairs with alternating feet. Before that, they kind of take one step onto a step and then put the other foot onto it, and it takes a little while for them to get it. And they're able to start and stop running. Doesn't sound like much, but for a little one before age 5, a lot of times falling is how they will stop a run. All right, so as their muscles become more advanced, as they learn how to use their muscles, they are able to hop, go up and down those stairs with alternating feet, and be able to start a run and stop it without having to like run into a wall or fall down. All right, that's around 5 years old. All right, so artistic development, it is going to go from these scribbles to then being able to see some shapes, to some designs, and then finally around 4 to 5 years old, it's going to look like more like pictures, okay, pictorial, and you'll be able to make out what the pictures are. Really before that, sometimes it can be very frustrating because little ones will bring up a picture and they're like, oh, do you know what this is? And it's just a bunch of scribbles to adults, or a bunch of shapes, and we can't really make out what the picture is until about 4 or 5 years old, and then finally you can get, oh, okay, that's a picture of your family, okay. So before that though, little ones can get so upset because in their mind they're seeing what it is. They know what those scribbles are, but an adult looking at it might have no clue what is going on until about age 4 or 5. All right, handedness. Little ones figuring out if they're left hand dominant, right hand dominant. That usually, you'll start seeing little ones figure that out by about age 3. They'll start using one hand more than the other.